Hello everyone. Today we are going to start again with the polymer. This is the fourth episode on the chapter polymer. So today perfectly we are going to state about the copolymers and rubber. So regarding copolymer, I have already told you is a mixture of one monomeric species. So one monomeric species when we multiply or when we go for polymerization and the compound what we form is a copolymer. In showing you nylon 6,6, you might know the word nylon has come from the word NY and LON. So NY means New York and LON means London. So this nylon was being formed by two different areas. One was from New York and from London, both together in the same year. So the word came up as nylon. Nylon 6,6, we have seen that it was made by adipic acid and also the compound which we have seen before as CH2 whole 4 NH2 NH2. It was called as hexamethylene diamine and adipic acid CH2 whole 4 COOH. So here you can see, student, that two different monomers when they are united together, they form here NHCH2 whole 6 NH C double bond O CH2 whole 4 and C double bond O. So this was nylon 6,6. Nylon 6,6. So it is a copolymer because you have taken here hexamethylene diamine and you have taken here the adipic acid. So here what we are forming is a copolymer. So in showing you, as I told you, this nylon, the word NY came from New York and lon here comes from London. So student, I will be showing you one more copolymers today, that is with butadiene. If I take 1,3-butadiene, double bond CH, single bond CH, double bond CH2, it is 1,3-butadiene, with styrene. If we take here styrene, so you can see here, student, this is styrene, STYRENE, styrene. This is one monomer, this is the other monomer. Now when we unite them together, as I have told you, this is the sigma bond, this is the pi bond, sigma bond, pi bond, sigma bond and the pi bond. The pi bond breaks. And when the pi bond breaks, so you can see here the pi bond breaks, one of it, so one half it goes this side, the other half goes this side. So you can see here forming CH2 single bond CH. Similarly this half, it breaks up here, this breaks up, it goes this side, the other this side. So it forms a double bond CH2, a single hand on the other side. Similarly, this also it undergoes a cleavage, and in doing the cleavage you have CH2 single bond CH2 CH with a benzene ring and the hands being open, they join here, and this is what we call it as Buna-S, B-U-N-A-S, Buna-S. Why the word called Buna-S? The thing is because the word bu has come from the word 1,3. So I will tell you once more here, the word Buna has come from the word here butadiene, and Ne means sodium. So here you have to give sodium, you have to treat here sodium, and you have to give a huge temperature and pressure. So in implying with sodium and temperature and pressure, you get butadiene with sodium, and S is styrene. So student, this is a copolymer. So because you are taking one monomer here, the other monomer is here. So two monomers makes a copolymer. Now let us focus more to rubber. If we focus more to the rubber now, Natural rubber, I will tell you this, I have already discussed about 1,3-butadiene, CH2 double bond, CH single bond, CH double bond, CH2. It's 1,3-butadiene. So when this hydrogen is replaced by CH3, it is called natural, N-A-T-U-R-A-L, natural rubber, R-U-B-B-E-R, natural rubber. This natural rubber, what we see is, we are getting it from the latex of the rubber tree. So students, you know, in South India, in Malaysia, in Cuba, the people there, they used to raise up the rubber trees and they make incision. They make incision. As we see here, we are using in the palm tree. খেজুর গাছে যেরকম আমরা কেটে রসটা ঝরিয়ে নিই, similarly you can see there in the natural rubbers there are incisions and they get the latex, and the latex is nothing but here this is called isoprene, I-S-O-P-R-E-N-E, isoprene. This isoprene is natural rubber, and this natural rubber, I will tell you that it forms like a coil. It is very soft. If you heat it at a high temperature, it becomes sticky even, and you cannot increase the strength, and it cannot take much of the load. It has got lot abrasive property, so it goes on abrasion, and so it is of almost very less use in our day-to-day life. So we are in mind to go with synthetic rubber. Apart from that, you know, like students here, this is isoprene. When we go for polymerization, what we will see is this half, this is sigma bond and this is the pi bond. The pi bond opens out. The pi bond opens out from either side, and we get here CH2 and then single bond single bond CH3. In this way we are getting it, and here it forms a double bond CH and then CH2. Remember here you can see carbon. Here this half bond forms here a double bond. So here you can see that CH2 and this CH2, they are on the same side, so it is called cis. So cis isoprene. So it is cis isoprene, P-R-E-N-E, cis isoprene. And this cis isoprene, again you can see that it is forming CA and then CH, CH3, CH2, and then here comes CH2 and then H. So you can see here that they are being attached with one another because this hand opens and they make chain, they make a relation between this compound with this compound. So in case of rubber, you can see the natural rubber, they are forming a polymerization, they are forming a polymerization, they are forming a polymerization. This is the polymerization. So with the CH2 group, they form the polymerization. So you have here CH2 single bond, C double bond, CH, CH3, and then CH2, one hand open. So these CH2 are the active sites where they go for the polymerizing effects. So students, what you have to see is that this rubber, it is being highly coiled, and this coil, it often breaks when it is cooled, so it is brittle in nature. Nowadays what we do, we go for vulcanization. We use sulfur to crosswind it so that it does not get deteriorated with very high temperature or under huge amount of pressure. It does not get deformed. It can bring back to the original state. So this portion, I will ask you to see, in case of the isoprene, when we are using sulfur, what happens is the double bond breaks, and it is again intervened with carbon, and this is again with the carbon CH2, this is H, and this is CH2, this is CH3, and this again, the double bond, this double bond breaks, the double bond breaks with sulfur. So in the similar way, it affects that sulfur helps in binding the state of the chain, the linear chain, and it does not make it to get it deformed under huge amount of pressure. Sometimes we have seen in case of vulcanized rubber, we are using for making the tires which can take heavy loads, the footwears, and similarly you can see they are filled with the sulfur, and sometimes we are using the fillers also. In between these gaps we are filling it with carbon. We are filling it with carbon. So this is very important. Some fillers are also used apart from that of the sulfur. This is all I can tell you about natural rubber. Natural rubber is called isoprene, and when they form a long polymer, so we call this as polyisoprene, P-R-E-N-E. So if we ask you regarding the natural rubber, you have to say polyisoprene. But if we ask you the monomer of the natural rubber, you have to say isoprene. So student, you have to see it once more. Take a note of it that here we are using sulfur to get those linear chain get entangled in such a way so that a huge amount of pressure will not make the chain break, and it will be making it highly elastic in nature. It will make very highly elastic in nature due to this sulfur. So vulcanized rubber is usually used in the markets. We will go for the next one, is about the synthetic rubber. Among the synthetic rubber we have neoprene, Buna S and Buna N. Students, we are going to learn about the synthetic rubber. So 3 synthetic rubbers are being used nowadays. One is about the neoprene. I will again draw the structure of isoprene, or better I say 1,3-butadiene. This is again 1,3-butadiene. When this hydrogen is replaced by chlorine, it is called neoprene. It is called neoprene. N-E-O-P-R-E-N-E, neoprene. And this neoprene, when you go for polymerizing effect, remember in this case also we have to use good amount of sodium and peroxides. Peroxides with high temperature and pressure, this breaks open CH2 single bond CCl. Here this half a bond, here half a bond, it makes us the single bond here, CH single bond CH2, and half a bond, half a bond. So here you can see this is what we call a monomer of this polyneoprene, what we call it as a synthetic rubber, and this goes on multiplying, here to being a big polymer. Usually we make around 11,000 to 20,000 monomers makes here the synthetic rubber, the neoprene. So hopefully you understood, student. Neoprene is very useful because it can be used in making the gaskets, you can use it in making the oil containers, petrol tank liners. All these are being used with this neoprene, and it is resistance to corrosion. We'll go to Buna S. Our next part of the synthetic rubber is Buna S. Here again we will be going back to 1,3-butadiene. We will be going back again to 1,3-butadiene. We will be going back to 1,3-butadiene with styrene. CH2 double bond CH and benzene. So it is also called as BSR. Why? Butadiene styrene rubber, or you can also call it SBR. That means styrene butadiene rubber. So how it works, let us see, student. When you are giving sodium, in the presence of sodium and the pressure and temperature, it forms here CH2 single bond CH double bond CH, single bond CH2 opens the hand to join with the styrene CH2 single bond CH and the benzene group. So they join hands here, they plug up, and when they join together, they form a monomeric unit called as SBr. This is what we call as Buna S. This is what we call as Buna S. And this Buna S is used more in the footwears, in making out the footwears. That means the sole of the shoes or chappals, whatever you have. It is also used in making the tires, nylon grip tires. And here you see Buna N, the same thing. This is Buna S. For Buna N you have again 1,3-butadiene. 1,3-butadiene plus you add here acrylonitrile. What is that acrylonitrile? CH double bond, CH2 double bond, CHCN. This is called acrylo, acrylonitrile, acrylonitrile, and this is styrene, styrene, styrene. So if you can divide and see it, then it forms again the similar way, CH2 single bond, CH double bond, CH single bond, CH2 opens the hand for uniting with acrylonitrile, CH2 single bond, CH and CN, and it joins hand. So when it joins hand, they forms a single monomeric unit, and this is what we call it as Buna N, B-U-N-A, Buna N. Why it does? Because you require here the sodium, here also you require sodium. So in the presence of sodium and at a very high temperature and pressure, it turns into Buna N. So Buna N is used more and more for just like the neoprene in oil containers, where you have to hold the oil because it is not diluted or it does not dissolve in any kind of petrol, diesel or any kind of oil. But you know, the natural rubber isoprene, it is dissolving in kerosene, in diesel, in petrol, and also in carbon disulfide, even in alcohol. To avoid it, they use here these synthetic rubbers. Synthetic rubbers are not dissolving in this type of solvents, so they can be used in different ways. This is the last part of the chapter polymer. We are going to see about the biodegradable polymers. You know students, polymers is more than a blessing, a curse. Why? Because though they are found in more and more readable uses, but they are not biodegradable. They are not degradable at all. And if they are not degradable, we just throw it off, and that creates a lot of pollutions, particularly in the land. So land pollutions, to avoid these land pollutions, we are planning to make polymers which are biodegradable in nature. You know, like when we throw away all these polymers, particularly when we just take some plastics and throw it off, it is going to make a lot of pollutions. It clogs the drain, this, that, and so on. To avoid it, we go for biodegradable polymers nowadays, and this biodegradable polymer is usually done in such a way that it contains esters. So if we can punch the esters in between the polymers, then the esters are of weak link. So as they are having weak links, we can easily break down by the help of the enzymes present within the microorganism. So when we throw away the polymer together in that waste materials, it reacts with the enzyme coming out from the microorganisms, and these microorganisms can help to break down. So I have given you here about biodegradable polymers that can be broken down rapidly by the enzyme. Whose enzyme? It is the microenzymes, enzyme catalyst reaction, which will help to break down the polymer into small particles. So it involves inserting the hydrosoluble ester group into the polymer. So just we are going to put the ester group, which is easily hydrolyzed, by the enzyme coming out from the microorganisms. So students, here we have glycolic acid, lactic acid and the hydroxybutyric acid. So here what we see is when we are going to punch it together, it breaks open to form OCH2C double bond O, and this OH, here this OH goes off, here H goes off. So you have this type of compound, and this is what we call it as polyglycolic acid, PGA, polyglycolic acid. So glycolic acid, when you are making it in the form of a polymer, joining hands with other polymers, we get here polyglycolic acid. In case of the lactic acid, you know, like this is the lactic acid, here we have, if we take out the hydrogen part and the hydroxyl part here, so you have OCHCH3 C double bond O, and the bond here comes. When we punch it together with the polymers, so being a weak link, it can be hybridized easily by the enzyme coming out from the microorganisms, and this is what we call as PLA. This is polylactic acid. So polylactic acid. And last to go is about the hydroxybutyric acid. Here also similarly we'll take the hydrogen out, here the hydroxyl part out. So you have OCHCH3 CH2C double bond O, the hand keeps open for it to join with the polymers. So this is what we call it as polyhydroxybutyrate. So polyhydroxybutyrate. So when you take polyhydroxybutyrate and lactic acid together, also you can get biodegradable polymers. In the market we have two polymers which are biodegradable in nature, which are readily used nowadays, is poly-beta hydroxybutyrate and with beta hydroxyvalerate, PHVV. What we are using? We are using here p-hydroxybutanic acid. So oic acid COOH, you are getting it, and hydroxy is the OH part. So from here we can remove the hydrogen, we can remove the OH from the butanic acid. So we can use it as making the ester. Similarly here hydroxy, in the 3-hydroxy, here you can see the hydroxy helps in giving the hydrogen out, have a link with the oxygen, and from the pentonic acid we can remove the hydroxyl part. So it is used in making PHBV. This is an important biodegradable polymer used nowadays. We have another more polymer, nylon 2 and nylon 6 is extremely important because it is obtaining naturally. This glycine is obtained naturally. Aminocaproic acid is also occurred naturally. We are getting it from the animals. So here you see NH2CH2COOH, and this is nothing but amino acid, the kind of amino acid which you will be learning very soon. So glycine and aminocaproic acid, when it removes one hydrogen out, so it gives NHCH2C double bond O. This OH goes off, here one H goes off. So one H remains, another hand remains open. Similarly here also one H goes off. It joins with a hydrogen NCH2. It joins with CH2 whole of 5 and C double bond O, and it opens its hand here to join together. This monomer, when you multiply into get a polymer, by the help of polymerization we get a biodegradable polymer. It is usually called as nylon 2. Why nylon 2? Because there are 2 carbon here, and here nylon 6 because there are 5 carbons, 5 plus 1, 6 carbon here. So students, here what you have learned today is about the biodegradable polymers. Biodegradable polymers, usually we fill up between the 2 polymer, we are filling between the 2 copolymers, we filled up with an ester link, so that ester, you know, it is a very weak bond, it contains weak bond and it contains a hybridizable ester, and it helps to break those bond with the help of the enzyme with the catalytic enzyme of the microorganisms. So student, we have two important biodegradable polymers nowadays. One is PHVV and other is nylon 2 and nylon 6. Hopefully you have understood about polymers and go through the lesson. You finish the NCERT text as well as the exercise part. If there is any problem, please consult with me at the